All right, so this chapter that we're doing, chapter 5, is about polynomial functions. What we've done so far, we've done linear functions, we've done quadratic functions. So that's first power is linear, second power is quadratic, and polynomial is the rest of them. So that's third power, fourth power, fifth power, and what the graphs look like for those, how we can tell if they're up or down and what that means. And where we know where the zeros are, or the parts where we cross the x-axis. So today we're determining the degree of the polynomials. The degree is the power, how many terms there are, what the end behavior is, what the zeros are, and how to write an equation if we're given just our zeros for our solution. So there's basically 5 or 6 main things that we're doing today. So like I said, I'll split it up, do the first part, then the second part. Okay. So each of our polynomial functions can be classified by degree and number of terms. So I'm just going to make a list of the degree, the name of it, and what a picture would look like of a graph that had that specific degree. And then I'll just do number of terms and examples of that over on this side. So we're going to kind of draw a line between, we'll do degree on this side and number of terms over here. So we have names for degree of 0, 1, 2, 3, 4, 5. And for number of terms, we just have 1, 2, and 3 have specific names. After that, we just call them polynomials or whatever degree. So the degree is the highest power. So the highest power in your polynomial is your degree. Degree 0 is called a constant function. It does not have a variable in it. And if it doesn't have a variable, it's going to stay the same the whole time. There's nothing that varies. That's why we call it a variable. There's nothing that changes. So we don't have any variables, no x's. And if you were going to graph a constant function, it just goes straight across. Constant graphs go straight across. They have no variables with them at all. They never change. An example of a constant function would just be like y equals 2. That's a constant function. It's always the same thing, never going to change. First power is called linear. A linear, you can look at that root word. Linear is going to be a straight line. It's not straight across, it's just a slanted line. It's a first power graph. The highest power would be 1. Remember, if you just have an x, there's an understood 1 there. The second power we've already done. That's what we talked about last. These are our quadratics. What is the shape of a quadratic graph? We've drawn a bunch of them. Our x squared, our quadratic. It's a U shape, right? It's our quadratic graph. And that's going to be x squared. A third degree polynomial is called cubic. It's called a cubic function because if you're thinking about a cube is in 3D, right? There are 3 dimensions for a cube: length, width, and height. So when you have those 3, we call those cubic functions. They're fun to draw. They're like little squiggles. They start and they're kind of like squiggle, squiggle, squiggle. So just up, down, up. Anyone want to guess a 4th degree? Anybody know? Remember from Algebra 1? Starts with a Q. Q, A, R. I forgot the U. There we go. It's quartic. Quartic is a 4th degree polynomial. I remember that because what are quarters? Quarters, that means you've broken something into how many pieces? 4 pieces. Quartic, 4th degree. A quartic looks like a W. It starts up and ends up and has some little loops in between. Up, down, up, down, up. And x to the 4th power is the highest one we see. Fifth degree is quintic. It starts down and ends up. So down, up, down, up, down, up. 1, 2, 3, 4, 5 here. So with every degree, you're getting like another section of your graph. So linear was just 1 section. Quadratic had 2, the down and the up. Cubic had 3, up, down, up. Quartic had 4, down, up, down, up. Quintic had 5, up, down, up, down, up. Okay, so that's the maximum number of changes that we can have, or sections of the graph, as based on the power that we're given. Anything more than that, you just say like 6th degree or 7th degree or 8th degree. They don't have any special names. So more than 5, it's just like 6th degree, 7th degree. We don't have any fancy names for those. We also classify based on the number of terms, and you guys have heard me say these all year, but just to reiterate what they are. 1 term means like 1 group of a coefficient, a variable, and maybe a power. Those are called monomials. An example would just be like 7x squared. That's a monomial. That's 1 term. Our 2 terms, y'all know 2 terms, right? 2 terms are called a... What can you ride that has 2 wheels? You can just mouth it. 2 wheels would be a bicycle. So for 2 terms, it's a binomial. That would be something like 7x squared plus 3. There's 1 term, there's 2 terms. And then 3 is going to be a, what's our prefix for 3? A trinomial, good. And 5x squared plus 2x plus 4, that's 1, 2, 3 terms. So I'm going to write 2 out. We're going to classify them by their degree and then the number of terms. So our first one, we have 6x squared plus 5x minus 4. And our second one is 7x plus 1. So we're going to classify by degree, and then also number of terms. So each of them is going to get two separate classifications. So for the degree, we always look for our highest power. What is our highest power in our first polynomial? Our highest power is 2. Good, that's our highest power. And there's 1, 2, 3 terms. So second power is a quadratic, and 3 terms is a trinomial. So this would be a quadratic trinomial. Amari, do you have a question?
No, my bad.
That's okay. All right, let's look at our second one. What degree, what's our highest power that you see for our second thing? If the highest power is 1, right? There's an understood 1 there. Our highest power is 1, and there are 1, 2 terms. So that's a linear binomial. Okay. Any questions about classifying by degree and number of terms? All right. What we're going to look at next is the end behavior. And end behavior just describes what the arrows are doing. So the arrows for like this first degree, those would be down and then up. The quadratic would be up and up, down, up and up, down, up. Do you notice a pattern with the arrows that we have drawn on those pictures and the degree? Anybody see a relationship between those two? Which kind of numbers had the up-ups? Which degree had the up-up? I had 2 and 4. What type of numbers are 2 and 4? Even, good. And the ones that had the down-up, that was 1, 3, and 5, and those numbers are odd. So if your degree is even, your arrows are going the same way. If your degree is odd, your arrows are going opposite ways. Okay? So we're going to make a chart to see that, and then we'll look at some actual functions and see. So it also matters what our leading coefficient is. Our leading coefficient tells us if it's positive or negative. That makes it let us know if our graph is up or down. Y'all know for quadratics, when it was negative, our graph would be upside down. So we're going to make an end behavior chart. Leading coefficient is just a fancy way of saying, is the number in the very front positive or is the number in the very front negative? So all of the graphs that I drew when we were looking at all the different powers, those were all positive graphs. I just drew you regular positive graphs, so we'll do those first. And then if you know the positive, can you get the negative just by flipping it over? Like if we know what it looks like positive, we'll just, upside down. So that means your arrows are just going to swap, and that will be flipping it till we'll have a negative leading coefficient. But for our even degree, both of our arrows were pointed up. And for our odd degree, it was down followed by up. There are two other ways that we can describe this rather than just our arrows. So I'm going to put these in the box as well. If you need to make a bigger box, that's okay. So another way to say this is that it rises to the left and rises to the right. So the left arrow is rising, which means it's going up, and rising to the right is the right arrow. So this would just mean rise right, rise left. I switched my right and my left. I'm sorry. So this is the left side. Geez. So rise left, rise right. This one isn't rising on the left, it is falling on the left. So down means it's falling. So falls left, rises on the right. Okay, that makes sense. Rising means going up. Falling is going down. Okay. We can also use infinities to describe this. If something is going up, it's going to positive infinity, right? If something's going down, it's going to what type of infinity? Negative infinity, okay? So going up is going to be going to positive. Going down is going to be going to negative infinity. So if you see the infinities, this would mean f of x goes to infinity. That's a positive one. Yikes, that looks weird. Just showing you all the ways this can be written. So they're going to say f of x is going to be the y part, like if it's going up or down. And they're going to also give you an x, and that's just saying left or right, okay? So if they write x to negative infinity, that's just the left side. X to positive infinity, that is the right side. So it's the same situation. They're just using infinities instead. So rise is going up to positive. Left is the negative infinity for that. This one is falling. So it's going down. And that's on the negative x side. This one's going up. So it's positive infinity. That's on the positive x side. All right, we're going to flip it over for our negative leading coefficient. So our arrows get swapped. So instead of up, up, these are both going to be which way? For an even negative, they're both down, down. So instead of rise, we're going to fall. Fall left, fall right. And our y value, that's our rise and fall. That's going to go down. This means x on the left. This just means x on the right. So it's the exact same thing. They're just using infinities instead. Left and right is x, up and down is y's. For negative odd degree, the arrows instead of down, up are up, down. So we rise to the left, fall on the right. Rise means our f of x is positive. Fall means our f of x goes to the negative infinity. So we're going to look at a problem. We're going to identify if it's a positive or even or odd degree, positive or negative leading coefficient, and then write down what the end behavior is or what the arrows are doing for our graph.
Can you give me like a second to write like the bottom stuff down so I won't be
Yeah.
lost when we're talking?
Yeah, I'll go slow when I'm writing these down too.
Okay.
Okay, try and fill out what the degree is of these and also what the leading coefficient is. So once you've written down those two polynomials, write down what the degree is and what the leading coefficient is. And then that's going to help us figure out how our arrows are going at the end of our graph. All right, for our first one, we have negative x to the fourth plus 2x. What is the degree of that polynomial? What's the highest power you see? 4, right? 4 is the degree. It's a quartic. And is 4 even or odd? It's even, okay. I'm going to write down that it's even. That's going to help me out in a second. And my leading coefficient, what is the number that's in the front? Is it a positive or a negative? It is -1, and that is a negative number. So I've got an even degree with a negative leading coefficient. So what are the arrows going to be if you have a negative even? So negative leading coefficient with an even degree. So look back at your chart. Go to even degree, negative leading coefficient. What are the arrows going to be? Which way are our arrows going to be pointing? They are both going to be going down, right? Even, they go the same way. They're either both up or both down. But an even negative, normally evens are up, but negative means I'm going to be flipped upside down. So even negative is this box here. Even degree, negative leading coefficient, it's this box. And our arrows are both pointing downward. So this one falls to the left and the right. And if we use the infinities, our y is going down on both sides. This means left. This means right. All right, our second one. Write down the degree. Tell me if it's even or odd. Then write the leading coefficient and see if it's even or odd. Not even or odd, positive or negative. Okay, what is our degree? Degree is 3.
Cubic.
Is that even or odd? That's an odd number. 3 is an odd number. Our leading coefficient is 5, and 5 is positive. So let's look. We have odd degree, positive leading coefficient. Odd, positive is going to be just the regular odd, which is down and then up. So on the left, it's falling. On the right, it is rising.
How you determine if it falls or rises?
If the arrow's going down, it's falling. If the arrow's going up, it's rising.
I don't see no arrows on our problem. You talking about like from what we wrote down earlier?
Yeah, once you wrote this down, you said this is an odd positive. So I went over to my chart and found odd degree, positive leading coefficient. So that's going to be this box. And these arrows are down and then up.
Okay.
So once you know the degree and the leading coefficient, you can know which box you're looking in. So the y's are the falling and rising, which is the f of x. The x's are the left and right. So left is always the negative infinity, right's always the positive. So on the left, it's going down. On the right, it's going up. Okay, we're going to take about a 10-minute pause for you guys to practice some of these in your CUDA. So this isn't 10 minutes just for you to do nothing. I want you to go ahead and log into the homework assignment. I want you to try and do 1 through 14. See if you can get those all completed. You don't have to write them down at all. 1 through 14, you don't have to write anything down. You're just telling the name of degree and a number of terms for some of them, and the others you're doing the end behavior. So you have to identify if it's odd positive, odd negative, and what your arrows tell you from there. Okay, so 1 through 14, I'm going to give you 10 minutes, then we'll come back and finish the rest of the lesson.
On the first part, why is it negative? Like after you put false left, why is it negative infinity and not just infinity?